So good evening class. Yesterday in the series of fundamental of maths, yesterday we were discussing about the distance between the two coordinates. No matter it was the distance between the any 2 points in the space. So today we will be discussing about discussing on the new topic, that is collinearity. As the name suggests that is collinearity. We, as we already know, a straight line, it is a combination of infinite number of dots. When we connect that dot one by one, we are getting a straight line. So the collinearity, it is a property of the points. If they will be lying on the same straight line, then the points are said to be collinear. I will be just giving some examples. We will depict some of the images which will show, which will certify my statement that how we are concluding that if any 3 points are lying on a particular line, then we will be calling that point to be a collinear point. So I will just show with the help of an example. See, suppose if one point is this, one point is this, and one point is this, and if a line passes through these 3 points, okay, if a line passes through these 3 points and it is entitled as A, B and C, then in this case the points A, B and C will be said to be, all the 3 points are said to be collinear points, because these all 3 points are lying on the same line. Because of that property, we will be defining those points to be a collinear point. So in this point, suppose if a straight line is there, point A is there, point B is there, but point C is here. So in this case, we can say that A and B are lying on the same straight line, but C is not lying on that particular line. So in that case, this particular example, it is a property of non-collinearity. The above example which I had already given, this shows the perfect collinearity property, because in this all the 3 points are lying on the same straight line. Okay. So there are certain clauses regarding the collinearity. There are certain terms and conditions, because the collinearity, it is a combination of at least 3 to 4 terms. So after satisfying all those terms and conditions, we can say the points will be collinear. The first condition is AB plus BC should be equal to AC. This is the first point. This is the first condition, that sum of A and B and sum of B and C should be equal to AC. Then we can say that the point A, B and C are lying on the same straight line, and these 3 points will be collinear. Second terms and condition will be there. Suppose we had already taken AB and BC. Now I will take the point BC and BC and AB. So it is the same part, it is the same topic only. AB plus BC is equal to AC. So this is the first condition which will prove that points are collinear. That is, the points are lying on the same line. Then only it will certify the next, you can say, procedure. So regarding this AB, BC and AC, AB is nothing but it is a distance between A and B. BC is also the same thing. It is a distance between the point B and C. And AC, it is a distance between the point A and C. Regarding the distance, as I had already discussed in the previous class, the distance between the two coordinates, we will take the reference from that class, and we will be seeing in some of the examples how we are calculating the distance and how I will be certifying the statement that the points are said to be collinear. The second terms and condition will be the slope of AB. Slope of AB is equal to slope of BC is equal to slope of AC. Okay. So this is the second method. This is the second modus operandi of finding whether the points are collinear or not. So in that case, we are calculating the slope. The slope of AB should be equal to slope of BC, and that slope should be equal to the slope of AC. So these are the two methods by which we are calculating, we are stabilizing the relationship between A, B and C, and finally certifying that A, B and C will be lying on the same straight line, and these points will be collinear in nature. Okay, so we will be taking some example. We had drawn a straight line. So we had drawn a straight line, and I had already mentioned the coordinate of those points will be entitled as A, B and C. The A will be entitled as, the coordinates of A will be A comma B plus C, the coordinate of B will be B comma C plus A, and the coordinate of C will be C comma A plus B. Now we will be using the distance formula so as to establish the relationship between A, B and C. So in that case, AB plus BC should be equal to AC. If this is certified, if this is established in this relationship, then we can say that these 3 points will be collinear. So we will be calculating the distance formula. Using the distance formula, we will be calculating the distance between AB. So AB is equal to under root A minus B ka whole square plus B plus C minus C minus A the whole square. Understood? So we will be simplifying this term as A square plus B square minus 2AB plus, this will be cancelled out, so B minus A the whole square. So plus B square plus A square on, it will be minus 2AB again. Okay, so it is A minus B the whole square plus B minus A the whole square. So A square plus B square minus 2AB, and again we will be using this term B square plus A square, and it is again minus 2AB. Understood? So it will be AB is equal to 2A square plus 2B square minus 4AB. Understood? So we will be taking the 2 out. So AB is equal to under root 2, that is 2 will be above, under root 2 comma under root A square plus B square minus 2AB. So it will be AB is equal to root 2 A square plus B square minus 2AB. It means it is A minus B the whole square. Over the root it is, so it is will be A minus B. So the AB will be equal to A minus B under root 2. So similarly, we will be calculating BC. So we had established the relationship between the AB and BC and AC. Okay. So we had calculated using the simple formula A minus B the whole square. First of all, we had calculated AB, which is coming root 2 A minus B. Then we had calculated BC, which is coming root 2 B minus C. And after this, we had calculated AC, and which is coming root 2 A minus C. Understood? And we had used this basic formula AB plus BC should be equal to AC for certifying my statement that these 3 points are collinear. So we had added both AB and BC. Post adding, we are getting AB plus BC is equal to root 2 A minus C. And we are observing that the LHS, that is left hand side, AB plus BC is equal to RHS, that is AC, that is right hand side. So we had established the relationship between the summation of AB and BC, which is equal to AC. So this established, this demonstrates that the sum of 2 AB and BC, if it is equal to the point side, that is AC, then we will be saying that these 3 points are collinear. Collinear means these 3 points are lying on the same line, on the same straight line. So this is one of the method, this is one of the modus operandi which we are following so as to calculate AB, BC and AC, and these 3 points are collinear. As already discussed, we had used the first modus operandi, that is AB plus BC should be equal to AC. That is AB plus BC should be equal to AC. Then we had established the relationship that these 3 points are collinear. Now we will be using the slope method to demonstrate that these 3 points are collinear, these 3 points will be lying on the same line or not. So using the concept of slope method, there are certain basic formulas which we are using so as to calculate the slope between any 2 points. Okay, slope is what? Slope is tan theta. Slope is equal to tan theta and it is denoted by letter m, small m. Understood? So we will be calculating the slope of AB, then we will be calculating the slope of BC, and we will be calculating the slope of AC. So post calculating the slope of these 3 points, these three segments, that is segment AB, segment BC and segment AC, we will be drawing a so you can say conclusion that whether these 3 slopes are equal. If these 3 slopes are equal, we will be stating that these 3 points are collinear. If the slopes are not equal, then we will be stating directly that these 3 points are not lying on the same line and the collinearity theorem will be not established. So we will be calculating the slope of AB. The slope between the 2 points, the formula is slope is equal to y2 minus y1 by x2 minus x1. Understood? So in this case, slope of AB, the point is y1 is equal to 2, y2 is equal to 4, x1 is equal to 1 and x2 is equal to 3. So we will be substituting the values of y2, y1, x2, x1. y2 minus y1, 4 minus 2, by x2 minus x1, 3 minus 1. So it will be 4 minus 2, 2 by 2. Slope will be 1. So we had calculated the slope of AB, which is coming 1. Now we will be calculating the slope of BC. In the slope of BC, the numerical value will change. It will be y2 will be 6, y1 will be 4, x2 will be 5 and x1 will be 3. So we will be substituting the values again to y2 minus y1, that is 6 minus 4, by x2 minus x1, 5 minus 3. It will be 6 minus 4, 2 by 2. That will be 1. Now the slope of BC is also coming to 1. Now we will be calculating the slope of AC. In the slope of AC, same formula we will be applying. Slope of AC will be equal to y2 minus y1 by x2 minus x1. So we will be substituting the values of y2, y1, x2, x1. So y2 minus y1, 6 minus 2, 4, by 5 minus 2, x2 minus x1, 5 minus 1, 4. That will be 1. So we are seeing here that all the slopes are equal. That is, slope of AB is equal to 1, slope of AC is equal to 1 and slope of BC is equal to 1. So in this case, all the 3 slopes are equal. So we are drawing a conclusion that if the slopes are equal, all the 3 points A, B and C are lying on the same line and these 3 points are said to be collinear. So these 2 theorems are there which we had discussed. In the next class, we will be discussing the area of triangle, which is an important part, which is a core part, which will decide whether the points are collinear or not, whether the points are lying on the same line or not. So this is all about today. So please see the method, like it, subscribe it, and please do the message if you want to have any information further. I am here 24/7 so as to support it. Please subscribe the channel. Thanking you for this.